I've put Florence's automaton engine inside the enclosure so it turns. In the end I lowered it a little bit more because when I looked at it through the window you couldn't really see enough of it, which is handy. I just added some little hexagonal brass spacers at the top. I'm now working out, sort of calibrating the stepper motors so I know what Florence will do with certain settings. I've put a rubber band around her mouth to stop it hanging open. I think she's a bit in awe of what's going on today. All I've done is to connect up her neck, the back of her head in effect, so that's stepper motor, so it'll lift it up and down. I've got that one connected through the normal brightly coloured spaghetti to the wonderful little Arduino, lovely, and a power supply for the servo motors because they take quite a lot of current. And moving over here, I'm fiddling around writing and improving the software for Florence. I've got a subroutines written that will actually, well, called MoveNeck. When you first switch it on, it drops the neck right down because you don't really know where Florence could be. So it drops her right down to try and cut down on sort of destructive forces on chains and things. Then it waits a second, and then it moves up to 90, which I found is facing frontwards, if you like. Then it's going to move up to facing upwards, which is 130 degrees, and then down to 20 degrees, which is at rest. So let's give that a go. Primarily, it'd be a good idea to move around to the front. Oh well, you stay there. Right. Okay, let's press the button and see what she does. So that's Florence looking up, and then at rest again. That's not bad. This is the MoveNeck function. You send it which position you want the servo to go to in degrees, and then the function connects that servo or attaches it to an output. It then sets a variable to 1, decides whether it's going to be adding degrees or taking away degrees, and then basically cycles round from where it thinks it currently is to where you want it to be, and each time it writes the new position, so the servo motor moves to that position, delays 50, which is 50 milliseconds. Then once it's gone round and is in the new position, it detaches the neck servo from that pin. And I only do this because I found that servos often chatter. That's a problem with servo motors. They chatter, constantly trying to get into the right position. And because I've got so many servo motors in this and I want it nice and quiet and want to limit the amount of current that I'm using, detaching them really works. You just detach them and they stop doing anything until you attach them again. And then finally it tells another variable, a global variable, where the new position is, so that next time when you come round, neck pos knows where it is. So it comes here, there we are, neck pos, takes it away, and then basically works out the difference and moves from neck pos to the new position. Thank you all. Now to connect up Florence's eyes and mouth. The eye control chain was getting caught up in Florence's head, so poor old thing, I've had to take her head off, and I'm going to cut a little bit of this away, her neck, because I've realised that's what it's hitting. So that's great, because the head's quite low down and the eyes are in effect closing. And even though the head's right down, they're looking ahead and then looking up. So that's really good without anything jamming. Because it's a gear, I thought I might as well use it. It's this little bit. So this is the gear it's going to bear against, turn, and that in turn is going to unwind this little red sign, or little red weight that's going to go up and down in there. So I'll connect that up now and see what that does. Lovely. Here's the working ocular azimuth gauge, or reader, I forgot what I called it, which moves as the eyes move. Azimuth is such a fabulous word, it really is. I forget what it means, but it's about objects moving across the heavens and things. It's a fabulous name. I have been using this spring steel that I happen to have to make lots of levers and pulling bits and pieces, linkages, and this lovely fine chain, endless chain. Endless? It means that each link is actually brazed somehow together, so it's very, very strong, very tough. Problem is that the links are just slightly smaller than the steel spring wire that I try and push through them. So it's a pain in the backside, and also to adjust to the different heights once Florence is set up, and I need to move this up or down a little bit because that's connected to Florence, that's connected to the servo motor. It's you just can't do it really. So a little top tip I've come up with. This is 3 amp chocker block, or 3 amp connecting strip. If you cut it open, you get a ready-made, purpose-built, oops, there you go, little link. It's brass with 2 little plated screws, and it is brilliant. The chain just drops through, and if I want a loop of chain, the little connecting block is large enough to have 2 pieces of chain. So I've formed a loop this side, and I can tighten it, adjust it, loosen it, move it up and down, which is brilliant. It's the way that I've decided to do a big pulley up here on the right. But because I've extended this so far, there's not really room for it, so I'm going to have to try and turn this round and have the head turning pulley on this side. Is the 3D printer printing a new instruction to replace the old Bakelite one on the kitchen door? Is the 3D printer printing a new eyeball for Florence? No, the 3D printer is printing a wonderful chest-bursting alien, which has now been painted by my son. 3D printers, the printer that just keeps on giving. So I've freed up Florence's umbilical, as I like to call it, and I'll try and ease this out. There we are. Get all the wires out. So what I need to do is to put that slot, make another one this side,